Imagine waking up one morning and seeing hundreds of cities all slowly drifting the same way, not because they decided to, but because an invisible current is carrying them. Now, make those cities into galaxy clusters, and you start to picture the mystery astronomers call dark flow. Back in 2008, a team led by Alexander Kashlinsky noticed something odd. Many galaxy clusters seem to be moving together in roughly the same direction, and quite fast, hundreds to about 1,000 kilometers per second. That's not the gentle random motion we expect from the usual cosmic crowd. It looked like someone, or something, was giving the galaxies a collective shove from far, far away. To measure motions on the largest scales, astronomers use the cosmic microwave background, CMB. Think of it as the universe's baby picture, light left over from just after the Big Bang. Galaxy clusters contain very hot gas that slightly alters that ancient light when the light passes through. If a cluster is moving toward or away from us, it leaves an almost imperceptible fingerprint in the CMB. That fingerprint is called the kinematic Sunyaev-Zeldovich effect, KSZ. Kashlinsky's team did that and reported a surprising pattern. Hundreds of clusters spread over large distances seem to drift in the same direction. In other words, a bulk motion, a flow on enormous scales. So what could be pulling them? Something huge beyond our horizon. The simplest and least speculative idea is that a massive overdensity, a supercluster or a huge mass concentration, exists outside the part of the universe we can see. Its gravity could tug on the stuff we can see, creating a coherent motion. Because we can only see so far, that tugger would live beyond our cosmic horizon, a leftover tilt from the very early universe. During cosmic inflation, the superfast expansion right after the Big Bang, tiny quantum fluctuations were stretched to enormous sizes. Maybe inflation left a slight directional bias, a cosmic tilt, that makes one side of our observable patch denser than the other, producing the flow. A neighbor from another bubble. Some versions of the multiverse picture imagine many bubble universes. If our bubble bumped up against a neighbor, that neighbor's gravity might influence ours. It sounds dramatic, but it's also hard to test. Or it's a mirage. The KSZ signal is extremely faint. Systematic errors, selection effects, or simple statistical flukes could produce an apparent flow where none exists. That's a real possibility, and scientists take it seriously. The dark flow claim lit a firestorm. Planck's satellite team reported no strong evidence for the same large-scale flow Kashlinsky found, which suggested the original detection might be an artifact. Kashlinsky and collaborators pushed back, arguing different analysis choices can matter, and a few reanalyses still see hints of a signal, though usually weaker. The community is split. If dark flow were confirmed, it would be a big deal, not because it threatens Earth, but because it would challenge our understanding of the universe's largest scales. It could mean there are structures or effects beyond what our current cosmological model predicts. But don't worry about immediate consequences. Even flows of 1,000 kilometers per second are tiny compared to cosmic distances, and won't fling galaxies into each other on human timescales.